In this question, we've been told that a non-uniform plank of wood, AB, has length 8 and a mass 100 kilograms. So although we're given a diagram, I'm going to produce my own just so I can annotate it the way that I like, and I can make sure all the forces are labelled and all the information in the question is present on the diagram. So this is the plank AB. We're told that it's smoothly supported at its two ends, so we can add some supports here. And we're told a boy of mass 60 kilograms stands on the plank at the point C, where AC equals 3 meters. So right here I can place C and lock in its position, being 3 meters away from A. The boy has a mass of 60 kilograms, which means he has a weight of 60 G. Now this is a non-uniform rod, so I can't exactly place the center of mass where I'm going to model the weight, but I can give a general expression that the distance between C and the center of mass, I'm going to call that X. Now the weight of the plank itself is 100 G, and this section off to the right, well, what's left here is going to be 5 minus X. Together, I know that the distance between C and B should be 5 meters, and if this is X, this is 5 minus X. If we continue with the question, we're given information that the two reaction forces at the supports are equal to each other. So we can call these both R, and there'll be no need for subscript. From here, we're asked to determine the distance of the center of mass of the plank from the point A. So let's start as we usually would. We can resolve vertically. All the upwards forces should equal all the downwards forces. So we get 2R equals 60G plus 100G equals 160G, which means R, or one of these reaction forces, is going to be 80G. Additionally, we can take moments, and we're going to take moments from A. For each of these forces, we need to consider what direction they're moving. So the 60G and the 100G will both produce clockwise moments, while the reaction force at B is going to produce an anti-clockwise moment. So we need the perpendicular distance multiplied by the force for each of these. So we get 3 times 60G, 3 plus X multiplied by 100G, and that should equal 8 multiplied by R. We do know the value of R. I'll substitute that in on the next line. So just tidying up here, we get 180G plus 300G plus 100XG equals 640G. So first off, we see that the G's can cancel here. They appear in every single term. And tidying up, we get an equation in terms of X, and X equals 1.6 meters. Okay, just be careful here. This is the value of X. The question has asked for the distance of the center of mass from A. So looking at the diagram, I need to go all the way from A to that center of mass. It's going to be 3 plus X. It's going to be 3 plus the 1.6, or 4.6. Part B of the question asks to explain in the context of the problem the model of the plank as a rod and the model of the boy as a particle. Well, as a rod, that means that the plank is going to be rigid and it's not going to bend. We're not going to consider any situations where it might be bending. Additionally, we're only really interested in one dimension, and that's the length of the plank. We're uninterested in its thickness, we're uninterested in its width. We can ignore all of those things. No need to introduce any complications. Our simplified model only considers the length. When it comes to modeling the boy as a particle, well, we're thinking of the mass, we're thinking of the weight of that boy acting all at one point. We're not going to consider how much weight is attributed to his left foot or his right foot. Is he leaning more in one direction than the other? Once again, those are unnecessary complications. We'll just consider his weight to be at one exact point, 3 meters away from A.